Bismillahirrahmanirrahim. Any finite set of non-zero vectors of a vector space V over the field F has a maximal linearly independent subset of the vector space V over the field F. Proof. Suppose the set S consists of the element V1, V2 up to Vn of non-zero vectors of the vector space V over the field F such that the spanning set spanned by the set S spanned by the vector of the set S is denoted by ta. Then by a previous theorem it is obvious that the spanning set spanned by the set S, the element of the set S is ta is a subspace of the vector space V over the field F. Then by the standard replacement theorem there exists linearly independent subset of the set S, linearly independent subset S1 of the set S, which also span the subspace ta of that subspace ta is spanned by the element of the set S. That is, let S2 be any set of vectors of ta which contains S1 as a proper subset, that is S1 is contained in S2. That is S2 be another subset of ta which contain S1 as a proper subset. Then there exists at least one element V belong to S2 which do not contain in S1, that is S2 is a superset of is a proper superset of S1. Therefore there exists at least one element V in S1 which do not contain in S2. Thus the set it is there exists at least one element V belong to S2 which do not contain in S1. Then the set S1V is linearly dependent because the element V is not spanned by the element of the set S1. Therefore this resultant set is linearly dependent set by a previous theorem. Thus the set S1 span the linearly spanning set ta, which is a subspace of the vector space over the field F, is linearly independent subset of S. This subset S1 is a maximal linearly independent subset S of the vector space V over the field F.